Then other is called the salary compensation optimization, right? So these two we'll discuss this today. Okay. Then second part of my lecture, we'll discuss the fundamental of deep learning, right? So deep learning, I'll tell you why deep learning coming to picture, what are the problems in a artificial neural network, so that people are interested for the deep learning. So am I audible, right? Am I audible, right?
Yes, sir.
Yes, sir.
Yeah, okay. So what is the objective? To optimize the salary structure of a particular organization, ensure fair compensation will be given, then improve employee satisfaction and support HR decision making. So these four are basically objective. And when you know the salary and compensation optimization is equal to paying the right employee, the right amount at the right time, most efficient way. So how the artificial neural network help to given the salary and compensation of the optimizations. So what are the input I'm considering? So input I've considered the experience, then education level, performance score, skill level, and market trends. So this skill level is nothing but your technical skill or the communication skill, right? Absolutely no problem. Any skill you can consider it. Then when you consider here outcome variables, the three outcome variables are there. One is called the predicted salary, then compensation band, and the bonus recommendations. We can call those. So here what happened, this today, y is equal to is nothing but we can call the y1, y2, y3 is nothing but function of here x1, x2, x3, x4, x5. This is the problem of the multivariate problem, right? Here input is equal to 3. So output is equal to 5. Now what methodology you have to adopt? First phase you have to data have to collected in different various sources. Then data pre-processing, I already told you by normalization is one of the pre-processing. Then model train, you have to ANN model you have to train. Then prediction you have to do. So this is called the output. Once getting output, you have to evaluate it whether the output having some error or not error, right? Definitely error should be there, but how much error is there, you have to evaluate it. The model architecture I'm going to explain here. The model architecture you see here. So one is called the input layer, hidden layer, output layer, activation function, right? And these are the input. As I already told you, these are the input like experience, education level, performance scores, skill level, and market trend. And this hidden layer is defined. I'm given suppose 2, 3 hidden layer or 4, 5 hidden layer. That depends upon choice is yours. So you can do it. But output is given predicted salary, compensation band, and the bonus recommendation, right? Now I'm explaining the code first, then I'll coming to the algorithm and R programming. So here what happened, these are the packages I have to define neural network. And the step one, I have to create the data set. So what data set I've created? I created 200 sample. So 200 sample, and in this data set, experience start from 0 to 20. 0 experience means the new fresher, BTech guy join in your company, having no experience, that is called the 0. Up to 20 years, this in terms of years, experience. Education level, I'm given 1, 2, 3. So 1, 2, 3 means 1 for the UG, 2 for the PG, and 3 for the master something we create. Then performance score, I define from 0, those having 0.5, the performance score is 1. Those having 0.5 less than, the performance score is 0. Like that, the 200 sample have to created. Skill level, I define here 0.1, 0.2, 0.3, like that. Market trend is given 0.41, 200. The salary, you define here 30,000 minimum to 1,50,000. So randomly they have created this value from 30,000 to 1,50,000. To these are the I assume these are the data set. You can create your own data set, no problem. Then bonus is that is called the added bonus is there. So that you can define at a 5,000 to 30,000 bonus. That's a variation of there. Then what I did here, I defined here data I have to find out the compensation band. The compensation band is nothing but I have to find out those having less than 60 is compensation band number 1. Those having 60 to 1 lakh, compensation band 2. Greater than 1 lakh, compensation band 3, right? The 3 band I've created here. And normalize, the data should be normalized. This is called the data cleaning process. You have to normalize. Then data will be normalized here in terms of data, normalized data. Then I have to train index from 70% data should be training, 30% data should be testing, right? So which data I have to training? All the normalized data I have to train. That's why I multiply by 0.7. You can multiply 0.6 or multiply 0.8. So absolutely no problem. Then the test having all the data of the minus index. Minus in means total is equal to 7. So minus index is equal to 6. So it will be train testing. And annual ANN model means here the artificial neural model. In this model, my output will be here. You see the output will be salary and experience, education level, performance score, skill level, market trend combined. Then I use here 5,3. So 5,3 means there were two hidden structure or hidden layer. First hidden layer having 5 neurons, and second hidden layer is equal to 3 neurons, as I already told you the last class, right? Then go for the prediction here. So the moment after prediction, I identify the prediction between the minimum level to maximum level. Then all prediction I compute here, salary, bonus, pay band. So all the compensation band I have to predict on the basis of the minimum value to maximum value. Then actual data I have to identify. So actual data means actual salary I have to compute the prediction salary. So total error is equal to actual minus prediction, right? So that minus taking the mod value, that I have to compute how much error will be there. Then after that, what happened? I compute the root mean square analysis, find the error between the pair of variables and the actual and the prediction value. Now coming to the R code, now see how it will work in the value of the R code, right? So this is the R code compensation bond. Yes, this is the compensation. So I close this one. Now see here installation packages. So let us compute here this one. The file name is equal to salary compensation optimization. I control here, control L.
Sir,
I installed the packages.
Sir, we are able to see only the PPT.
Oh, R code not visible. Okay, top sharing. I share the PPT. R Studio. Total enter screen I can do. Screen I can do. Now visible.
Yes, sir.
Yeah. So now the installed packages. So this is the predefined packages are there, right? When you import like in a Python, here is called the install. So neural net is already predefined program. You have to install package when you use a particular package. So that's why neural net I'm using. So this package you have to install. So install all packages, then library also can install, then run the program. Now see automatically invoke all the programs. And this set.c.123 basically use for the random number. When you create a random number, this program you have to use that command set.seed123. This is a command 123 is a program that you have to use because I am using some random number I can generate here. Then the first page what happened? Create the data set. As I told you, the first create the data set. So data set I bake in a data. So this is called the data frame. In a R programming is called the data frame. In SQL is called the database, right? So in that case, what happened? The experience have to count. Run if means random number created. How many? Now 200 number of sample. Now you can see run if you create here 200 number sample starting from 0 to 20. Randomly they have to create, right? Suppose employee number 3, employee number 2 is equal to 5, random number. So the command is run if n, comma, minimum is equal to 0, maximum is equal to 1. Similarly, education level, then the performance score. The moment you run this one, so there is no error. Suppose you computed here data, you see the just data you can type, you data will type, you see the output of this. See, these are 200 data points are coming. The 200 data points, right? Suppose the experience, the first is the experience, the 13.6%. Random number means here the point value must be there, right? 13 years, 65, 6 point month might be, right? So like that, 1, 2, 200 data points are there, right? All the data points have to create it. Then on the basis of education level, performance score, skill level, market trend, salary, and the bonus. In this way, I create. Then this data have to find the compensation bond. You have to fix a bond, how much band you have to give in, 1, 2, 3. So having 60,000 compensation or 1 lakh compensation, that you have to decide. Then the normalized data you have to do. Data will be normalized. If you want to see the normalized data, you can find here data.norm, data data, then underscore norm. Now see all the data point from 0 to 1. Previously what happened, some value is there, so decimal value and 13 here also all having 0 to 1. Okay, that means data are from 0 to 1 normalized. Then after that I start the split data into 17 to 30. So I make a 17 to 30. Then I define the neural model. The neural net model, I given the 5 number of neuron in a first hidden layer, 3 number of neuron in a second hidden layer. So we can find here some neural net is not running. So you have to find here install.run again. So it's not recognized. No. Then you can run the model here. Then you can run the model. Then after that you plot the model. Model is not running here coming. Yes. Now see output visible. Is it output visible? The diagram visible? The neural network diagram.
Yes, sir.
Now you see there is a below they mention here step is equal to 42,009. That means this number of time is running that particular program, right? That particular program. An error is given 14.13. The error is given. And this error is nothing but your actual minus absolute error. Actual minus a predicted value, right? So automatical error. And these are the value we are seeking here 6.09 minus 1.78. These are called the weight between each variable. And these 111 are called the bias. So bias, I already told you what the use of bias. A bias will be input to the directly after getting the summation of Wi and Xi. After that, what happened? I'm going to that diagram in PPT again. After that, what happened? The data frame, once you create, prediction, you have to do it now. Computational model, I found the prediction 1 to 5 because all the 5 data points have to predict. So we can predict the value. Then this will be denormalized to do. So why denormalize do? Because the input variable will already normalize, but input variable you are not given the normalized data. After getting you denormalize, right? So that's why what happened, demoralize can do, denormalize. Then after that you can do normalize. So that time you can do on the basis of salary, bonus and compensation band. Because why? Because these are my 3 output. So I'm making this output. Then I compute here root mean square error to compute the performance of the particular result. Then I compute the result is equal to this one. Then finally I have to print the result. Print means head the result. Now you see here the moment I getting, you will getting here actual salary, predicted salary, actual band, predicted band, and actual bonus and predicted bonus, right? So in this case, what happened? The actual salary is 11,000, 1,12,102, but predicted salary become 1,04,205. If you difference minus, so it will be 8,000. So almost equal, right? Almost equal. So even also 1,44,000. Now see here 43,000. His quite difference is around 1 lakh difference. So this is not actually we can call the acceptable rate, right? Now here what happened? The actual 54,000 salary. Here what happened? Predict having 1 lakh. So it also not accepted. So 1 lakh 10. So here 99. Almost may be accepted. But here 1 lakh 20, 95 in may not accepted. Here 31 422, here 31, 522, it also accepted. So here what happened, out of 6, 2 only accepted and rest are not accepted. That means that in particular data, actual salary in the salaries component, that neural network is not given the satisfaction result. Now coming to actual band, that is the compensation band. See, the first actual is 3, prediction is 3. Here 3, here 1, here 1, here 3, here 3, here 2, here 3, here 2, here 1, 1. That means probability saying that more than 70-80% data having accurately predicted, right? Similarly, actual bonus, suppose you predict the bonus is equal to 6971,000, but here given predicted bonus is too much high. Here 55, here 21,000. You here 13,537, 15,235, 239. So almost this is only acceptable, and rest are this one, third one, and the last one is acceptable, and others will not acceptable. So going to details, you go to then PPT again. I'm going to explain here. This is my output. Now you can see the salary prediction model show large deviations. Now you see too much deviation. This is a 46, 98, too much deviations are there. This is the output. Then what happened? Actual 46K, but prediction, but 98 is overestimated, right? Similarly, 124K prediction 180 is underestimated. So that's why what happens. The salary prediction, artificial neural network not given that much of satisfaction result. But here, ANN is not accurately predicting the salary, and error is high and inconsistent. That's why you can see the moment you see the error is equal to 50. And this error is called the overall error of this network. Overall error means error of the experience, error from the education level, error from the performance, error from the skill level, and the market rate. So total on basis of we are getting the salary, bonus, and the compound band, right? On the basis of these three, we conclude that here, this particular model and not give that much of accurate result, right? So let us see, we can find another way. Suppose this is the model we can generate. In terms of model, we can create the data model. So this model I can create here instead of 5, 3. Suppose you can create, suppose 8 and 4. Let's see what the result is coming. Okay. Let's see the result is coming. Your result is more train. It will give accurate result or not. Then the output. So I'll show this one. Now remember 14.13 error. Next time see how much error. Then this one. Now see error become 9. Now you observe, previously error become 14, now error become 9. So this model is quite acceptable as compared to the previous model, right? Because you give me the less error. Because you are always being a data analytics, you always seeking for the less error data, right? Now look at here, instead of 6, now almost see here what happens, actual bond or predicted bond is almost equal, right? 20, 22, 28, 22, 23, 20. That deviation is very, very less, right? In this case also 115, these two most deviation, but this is less deviation, third one is less deviation, like that, okay? So in this error, what happened? So this model give quite result in the 30,223 running. So error will be 9.26. So what do you conclude here? Previously, I compute with a neural network having 5 number of neuron in a second hidden layer and 3 number neuron in a second hidden layer, or 5 number neuron in a first hidden layer. When you compute the number of hidden layers is more. In case of 5, 6, I compute here 8 and 4. So what happened? The accuracy will be more and the error will be the less, right? So that will be the conclusion. Now, if you compute more hidden layer, so time complexity, what happened? The computational complexity will be increases, but chances of error will be the less, right? So in this way, you can compute. Suppose you can compute, suppose here 10 and you compute suppose 6. Suppose you can see here, you can result, I don't know what the result. So you can find here what the error will there. So you compute the error should be less. No, error will be 9.2. So almost same. So here saturation, the network become saturation, right? So 9.2, 9.3 error is there. So in this way, you can find another hidden layer, suppose 3 and 4
Sir,
and
but it
5
is
and
same.
hello?
Sir, it is same. It is 8 neurons only in second layer.
Second layer is not running. I think it is a closed one. Okay, because close the figure. Figure have to close. Okay, parameter is invalid. Okay, you can put 8 and 6 suppose here. Weights are not calculated. See too much because less data are there. If you input the hidden layer is more, automatically weights are not calculated same. Let's see what the output again. It will take some time to getting the output because in backend the program is running on.
Sir, this
The,
number of hidden layers
yeah.
and the neurons is dependent on us or
Yeah, purely depends upon. See, I already show you the fast hidden layer 5.3, 5.3, and the moment is 8.3, given less error, right? So in this way, you can do high heat and trial method. Whichever is not there, you can compute. So here what happens, this number hidden is not taking 8 and 6. So weights are not calculated. So they are unable to weight the calculated, right? So you cannot go for the 8 and 6 because I already told you the input layer is given 1, 2, 3, 4, 5, 6, but output layer, hidden layer is 8. So that's really always you can take the less, right? And this type of problem overcome in your deep learning concept. So this is the one way I can show you how to compute the what we can call the error should be reduced, right? Now, similarly, see, in this case, what happened? The error will be the 15, and I already show you error will be the 9, right? So in this way, you can reduce the error. Coming to the compensation band, you can call the how the analysis is done. So correctly, like identifiers, the model sometimes predict the higher band than the actual. Bonus prediction is a regression is there. Actually, 6683 prediction is too much high, right? So too much high. And similarly, what happened, the predictions are unstable in case of my previous running the program, right? Similarly, what the improvement we can do? Now, the real HR data set can do it, or normalize is not may not be properly, or train. So, third point we did train the longer time, tune hidden layers. Instead of 5.3, I use here 8.6. And this is the example of the train longer time and to the hidden layer. Right, in this way you can do it. Now coming to the components performance, the salary prediction performance is very, very poor. Bonus prediction also very, very poor, but anyhow compensation band become moderator. Because out of three, the two are being poor, that means this model you have to reject. Why reject? Because the probability of this model is very, very less performance because two are poor, one is moderator, right? Now coming to the salary prediction using artificial neural network. In salary prediction, what the meaning? The meaning I'm going to say, suppose a new employee you are recruiting, so how much salary you will be given? So there may be some regulation from your company, but in the overall sense, suppose a new guy is there or something conflict is there, then how you automatically ANN can basis the predict the actual salary of a particular employee on the basis of their experience, on the basis of skill set, on the basis of their knowledge, or on the basis of age, any other parameter, right? We'll discuss in details. Suppose in description what happened, I'm saying the input I'm given here, the experience, education, and skill, right? Now we can put it here. So why not to consider the age is one of the factor, right? Age is maybe factor, but what I feel that age may not be a particular input for the salary compensation, right? Salary you can fix. Salary fixation age may not be a factor, right? You can put any such relevant factor. Suppose someone saying, sir, why not put gender? Are you thinking gender is one of the crucial parameter for identify the salary? Identify the salary. Are you getting what I'm saying? Is gender is one of the parameter? Tell me yes or no.
No.
No. So gender is not. So when you consider being a analytics, you have to find out what are the basic input must be there in case of neural network only. This is not in terms of deep learning. I'm telling deep learning no need to give the input as a parameter, right? Deep learning automatically they extract the features. You no need to give the input parameter, right? Automatically they extract feature. But when you apply any artificial neural model, you have to give the input as a neuron. So that's why I'm considering here experience, education, and skill. And this skill is nothing but technical skill plus soft skill. I consider both the skill and divide by the average. I'm taking this one, right? Or we can take the technical skill T skill, comma S skill also, you can do it. So what is my expected outputs? So expected output salary in terms of INR or USD, whatever you can tell. Hidden layer, consider the two layers. So first is called the 5 neurons and second is called the 3 neurons, right? In this can consider. And activation function is nothing but the by default sigmoid I consider, because sigmoidal is nothing but 1 by 1 plus e to the power minus x, and this x is nothing but one input variable of a particular output of the neuron. So what is the key points here? So here is nothing but a nonlinear relationship between employee features and the salary, and the normalize is mandatory. You have to find out about the better performance of the result and can be extended with the real HR data set. So real HR data set may be the key points here. Now coming to the result and interpretation. So this is my result. I show you my R programming code. This is the result. The actual salary we can fix, suppose 40,000. The predicted salary is given 41,704, is nothing but almost acceptable, right? So 40,000, 41,000, you can acceptable. You can compromise 1,000 by the company. Similarly, here what happened, actually salary 45,000, but predicted salary 43,000 also acceptable, because the difference is not that too much high difference, right? Similarly, the another employee 55,000 actual salary, but the predicted salary is equal to 56,000. That also you can call the acceptable, because the very close means the R square value very close to 1. So in this case, what happened? The actual salary, predicted salary almost near to equal, right? Now the predicted value are very close to actual salary. That means the model is a very good model, and model has a very less error. We can find now. Look at here the below bottom. So you see the error is equal to 0.003439, right? If you taking up to decimal 2, absolutely error, there is no error, right? So this model is best fit model in the basis of the experience is given, education is given, skill is given, but you predict the salary. You can put any other input data, absolutely no problem, but which is must be related to the salary. And this model give the output after 37 iterations. So what you can sell being a analytics, we can say that this ANN model, it demonstrate the good predictive performance with only minor deviation, and this minor deviation is always acceptable. Now you can see error is always there. I'm always telling every time, every program, every model in machine learning, error must be there, but error should be minimized. You cannot say that my model, my neural network model, my we can call the machine learning model, error is equal to 0, is not acceptable. Error definitely 0, because human being also error, right? Human being also intelligent, they also having error. Error always is there, but error should be minimized. So it's a good predictive performance with only minor deviation between the predicted salary. So this indicates that model is reliable, and salary prediction, they can effectively helpful for the HR analytics for the decision making. So once you create a model, and this model you create a chatbot, and you give the data, automatically you give the output. What data will be given? You did get data is equal to experience in terms of years, education in terms of years, or you can call the UG, PG, or the UG, PG and the PhD like that, or master, and skill, technical skill, or now you can give, automatically they give the salary. So you no need to compute, you no need to analysis how much salary you will give. You have to fix the meeting, you have to call the meeting, you discussion with the candidate. No need to do. Immediately you apply a model and data you have to fix. Automatically the payment will be the fix, right? So this is the overall data you can got it. Now coming to the my program, I can show you the same program. So this is the salary prediction already completed. I'm going to another program. So this is called the salary prediction by artificial neural network by giving the input you can give it, right? So let's see. So here what happened? The code is visible now. Our program code visible?
Yes, sir.
Hello? Okay. Now I'm going to here same process you have to do. Every ANN program you have to run the program for the library. You can run the library first. Then if you don't use ANN, no need to run the library. Then I create a data set, and this data set is nothing but label data set. I make the scale is equal to 1 to 10. Experience is how many variable? 1, 2, 3, total number of 10. So 10 number of attributes are there, or 10 number of employees are there. I'm taking the experience is equal to 1, 2, 3 like that. Education 2, 3 up to that 2, 3, 4, 5, 6 is there. Skill also depend to 2, 3, 3, 4, 6, 6, 7. I define like that. Then salary, this is my outcome variables. So this is the outcome variable. I just fix. And this is called the one instances, right? One learning. So what is one learning? A person having experience is equal to 1, education is equal to 2, skill is equal to 3, so salary is equal to 25,000, right? This is my perception, right? I fix like that. Similarly, experience is equal to 2, education is equal to 3, and skill is equal to 4, the salary is equal to 30,000. Similarly, any person having experience 10, education 7, and skills 10, so it is 70,000. So these data you have to given to the neural network, right? And remember that the data should not be vague data. Data should be inaccurate data you have to given. And the model, the neural network will be train the model, and you given the new employee data. Suppose you given experience is equal to 3, education will 4 and 7, automatically you will give the output, right? This is nothing but what we can call the neural network work. This is called the beauty of the neural network. Then after that, what happened? You same thing. You can do the data set. I compare here program. Now, when you write the data set here, you can write data. Now you can see all the data are there in like that. Okay, you can see the data point here. And simplicity, I'm taking. See, sometimes I'm taking random data. Sometimes I'm not taking random data for easy to understand you, right? Then I use the here Control L. The screen should be clear. Then you can put here normalize the data. Normalize data. Data should be normalized. So normalize 0 to 1. So once you normalize the data, you can see the output of the normalized data. Data normalize the functions. Data should be normalized. Then after normalized data, you can see the data underscore norm. You see all the values should be, you can type here. See all the data should be normalized, right? Now here what happened? You can find here, run the program here. Model you have to run. Then when you run the particular model, plot and model. Now you see 0.004 and step 31, right? In my PPT, how much is there? In PPT, 0.003, step is 37. So when I did yesterday night, I just put the picture. After running, is showing 0.03, but today running 0.04, right? Little bit, just a minor difference is there. So absolutely no problem. Then when you run the program on the basis of this model is run, then after that prediction model do, let me see the result here. Now look at the result here. Now actual salary 40,000, predicted salary also 41,704, absolutely no problem. 45,000, 43,151, 55,050. So a little bit prediction, little bit higher end, right? So little bit higher end on the basis of the experience. So what artificial neural network tell? What this model tell? Model tells on the basis of this input, so we'll get the actual and the prediction salary, right? So when you compute this particular data, so you can find here the data is very, very close in the accuracy result, and that's why the error is very, very less. So in this way, your artificial neural network the train, right? And the output we can rely on that. So any doubt on this? Tell me. So I think already 6 and 7 case study or application we have discussed by using artificial neural network. You have any doubt, or we can switch over to now we go to the deep learning concept. I'm coming to deep learning now. As of now, neural network is over, right? A machine learning is over.
Sir,
Ah,
sir, I know Anand also asked the same question that this
ah.
hidden layer, so for someone who's actually working and let's take the output expected is a recommendation or a prediction, right?
Yeah,
Based on
yeah, yeah.
inputs that we have. So is it like that based on my input and the output that I have expected, the hidden layers are created automatically? No.
No, your question is how to create hidden layer, right?
Yeah, I mean, but my question is, based on the input and based on the output, does the hidden layer gets created because there's a logic already, or
No, there is a no such thumb rule says there how many hidden layers you have to create, right? But you have to do one thing. Suppose you randomly create hidden layers, as I already show you 5.3. First hidden layer 5 neuron and second hidden layer 3 neuron, and showing the output is equal to 13.86 error is there, right? The moment I change the hidden layer, instead of 5 3 I make it is 8 and 6, then what happen? Error will be less. Instead of 13 it will be 9. Similarly, what I'll do is just like a hidden trial method, you make the hidden layer in such a way that you have to find my data should be fine tuned. My data should be fine tuned so that what happen, my objective is the error should be less. Your objective is error should be less, right? If error should be less, then only the model will be rely on that, right? You can rely on that model. So your target is the error should be less. The what any particular model having less error give the output, and that output you definitely will rely on that, right? So what will do? You make a hidden layer gradually increasing one by one parameter. The moment you identify the error is less compared to the previous run the program or previous model, then you can stop that. So this is the way we are doing. Being analytics, we are doing. So automatically the hidden layer we can generate it in case of artificial neural network only. Hope am I clear you?
Yeah. Professor Mohanty, can I comment to Shravan's question?
Yes, yes.
Shravan, you were asking the question whether who will be predicting the hidden layer, right? If I'm
right?
right, yeah.
Correct.
So
Yes.
I gave you a question on L'Oreal. Have you gone through that?
Yes, we did study that. Yeah, I did. Yeah.
L'Oreal, say suppose L'Oreal has to sell a product in a particular market, and the success of L'Oreal is because of the multicultural managers, right?
Correct.
So if they're hiring a manager, what is the reason behind it? The manager will be able to predict or sense make the culture. Like say suppose the beauty product is launched in a market, so it varies from culture to culture.
Correct.
Customers, let's say the hidden message within the customers, say perception, it is a hidden message. Say suppose you discussed about or you have given a narrative, and there is some message in that particular text or in that particular message, and you are able to predict that the person wants a particular product which is most suitable to the skin tone or maybe certain other things. So these are the hidden messages, or what is in his ANN terms, he's interpreting it as a hidden layer. Is it clear?
I got
So
it.
you can better relate it to that case study. That case study is it's a deep learning case study where you have used random forest, you have also used NLP, and one more NLP and sentiment analysis. So you can analyze that case study. What he is explaining, that hidden layer, we can analyze that. It's a kind of a multi-model method where three different perspectives have been used. When because it does not depend on only one say random forest technique, but it uses different techniques. So what you all of you can do, go back and take that case, you try to interpret, analyze the logic behind if what is the business problem? The business problem is L'Oreal is competing with some other competitors, and because it started as a French company and it is now a global company, so in global market it has adopted. It's a kind of like what strategy it has adopted, and so it is analyzing. And the success of this company is the multicultural managers, multicultural hiring strategy, the teams, the new product team. And how is the team working? Team is sense making the market. So it's a sentiment analysis. And then you can see what is the output. Output is the sales. Output is the product units of sales. So you can analyze it and put it in the form of what, how can we convert it into a random forest example? How can we convert it into, say, NLP? So once you take this, try to interpret, then you can understand this concept better. I will be providing the solution. First, you work on it, then I'll provide the solution.
Noted, ma'am. Thank you. Thank you. Ma'am,
Please go ahead.
somehow to the previous example, Mohanty sir, I'm sorry, I'll take another minute. I think Aditya was trying to ask a question about how, you had talked about various parameters recommending of a salary. So it's trying to understand that we had actually considered education to become a parameter, but then when we
Yeah.
considered experience and skill, does it still hold good?
Yes. Huh?
Yes, it holds good. Education, experience is the number, tenure, and skills. Instead of skills, you can take it as also as competency, knowledge, skills, attitude, aptitude. You can include many more.
Thanks, ma'am.
Okay.
Back to you, sir.
Thanks. Thank you.
Okay. Any questions, or should I proceed to introduction deep learning?
I am good, sir. Rest up.
Okay. So I think no question. So before I start deep learning, I give very easy analogy so that you can easily understand. And any doubt you can ask, so that it's a very interesting topic you can discuss more. Okay. I'm given very simple analogy, right? Suppose these are the basic term in a deep learning. One is called the data, second is called the model, and third is called the training, and fourth is called the output. Every deep learning model is there. Okay. This is just the structure of the deep learning, right? Now, suppose data is equal to book. Data is equal to book. Model is equal to student. Training is nothing but a studying, and output is nothing but the exam result. Exam result either pass or fail, right? So in analogy, what happened? A student is called the model. Student use the data in terms of book, read the data, compile the data, store in your memory, then this is called the process of the study. Then when you appear the exam, retrieve from the memory, read the questions in examination, compile which question suitable the answer, then write, then evaluate your performance and given the pass or fail mark. So this analogy will give idea how deep learning will work. Deep in the sense number of hidden layers. So that is called the deep. How much deep is there? How much hidden layers are there, right? And in deep learning, you will not read the KNN, you will not read the K-mean, you will not read the random forest, nothing. You cannot read all these things. Deep learning is nothing but the advanced versions of ANN, only artificial neural network. Advanced version of artificial neural network is called the deep learning, right? Now you clear for the analogy? Now the key terms are there in a data. So data is nothing but any type of data, maybe image data, maybe text data, maybe number, any decimal number, integer number, any number of data. Model will be nothing but a system we can learn, and training is nothing but learning process. And here output is nothing but prediction. And once you getting prediction, we can find the accuracy of the prediction. How correct the answer is. Suppose 80 is their accuracy, that means 80% are correct. And every deep learning model, no deep learning model will give 100% accuracy. No deep learning model as of now give 100% accuracy. So deep learning basically is simple teaching a computer system or any model to learn from the example and improve over time, just like a human, and but faster than with the more the data. That's why we can find each deep learning model we can suitable for problem to problems. Suppose I have one problem, that model may not be fit for your problem. So your problem, what deep learning model may not be fit with XYZ. So what if depend the deep learning model is vary from problem to problem. So that depends on what is exactly you want to do. As per your problem specification, you have to develop a deep learning. So this is the overall concept. Now I'm going to very depth about the introduction to deep learning. Then we'll go to the case study using the deep learning by the shape data. Now the question arises, when you apply the artificial neural network, when you apply the artificial neural network, when you apply the deep learning. Only one case you can say that depends upon the data. Depends upon the data. If data is too much high, too much means we can call the 1 terabyte, more terabyte number of data, then deep learning will be well performed. If the less number of data is there, suppose whatever I discussed today, all the 10, 20, 200 data, if you perform deep learning will give the result. It's not like that give a result, it give the result, but it may not be accurate result. So for that, the artificial neural network may give the result, right? Now coming to the introductions. Deep learning basically transforming the way of the machine understand, learn, interact with the complex data. So this is nothing but the complex data. What is the complex data? Complex data is nothing but your image data, or you can call the structured data, semi-structured data, or unstructured data. So these all three are there, right? Then again, deep learning mimics the neural network of the human brain. It enables computers autonomously uncover the patterns and make informed decisions from the vast amount of unstructured data. If structured data is there, then deep learning also work. But deep learning is more will work if you combine huge number of data, mixing up unstructured, semi-structured, and the structured data. Now coming to artificial intelligence versus machine learning and deep learning. In 1916, Salmon started introduction of artificial intelligence. Before artificial intelligence, we call the expert system. You remember my first class. First expert systems was there. After that, what happened? It will changing to artificial intelligence in 1956. People are changing the artificial intelligence by in terms of reasoning. So artificial intelligence is nothing but a computer science. It's a combination of psychology, computer science, or linguistic, mathematical model can perform tasks require a human-like intelligence such as reasoning, problem solving, planning, understanding, and natural language. So this is called the you can call the antecedent consequence like that. The artificial intelligence will work. After that, what happened in 1968 or 70 around, the machine learning coming to picture by Mitchell said that Tom Mitchell is nothing but the experience E, then the task T you have to perform and measure the performance P. So these are the very, very terminology are using. Experience E, you have to perform you have to solve the task T on the basis of your experience, then to measure the performance. So this is called the branch of the AI. So here also machine learning, deep learning, both are the branch of the AI. Then fine tuning comes to the market. Now deep learning people are using, and deep learning are more popular in Japan, South Korea, China. They are people in 1998, but people are in India. They're coming around 2010 or late 2010. So deep learning by saying that the subset of machine learning that uses a artificial neural network may be layers automatically learn by the complex pattern. So what is the meaning of automatically? So in this artificial neural network, what happened? You are giving the features like experience, age, or you can call male or female, food experience. These input are given. But deep learning, no need to give input. You give the structured data, whatever data you have to give, no need to give features. The deep learning having some own power, he extract the feature automatically, then you do the analysis. So he will do the analysis. So a feature extraction is very, very useful for the deep learning. Unlike traditional machine learning, it can extract the feature by its own. Extract the feature by its own. This is very, very important. Extract the feature by its own. making useful handling the unstructured data such as image, speech, and text. Now, I've given one example. Suppose a small kid is there in your home. You are showing two picture, cat picture, right? The cat picture, you are showing one cat picture to a particular small kid. Then you are saying that this is cat. Then how a particular kid are observing it is cat or not? That means he observing the head of the cat, observing the eyes of the cat, observing the nose of the cat, observing the ear of the cat. So after 10 days or 1 year, you given the same image, then you ask, name the animal, who is this? Then you can tell, the kid will tell cat. How? That means the kid automatically observe the head, mouth, ear, eyes, tail, body, everything you observe. Keep the memory. The moment you showing the new picture, animal, automatically he gain, oh, this is cat. Like that, in machine that simulate the human intelligence, that is called the AI. The system that learn from the data from explicitly program, we call is a machine learning. Then data deep learning says that advanced learning using multi-layer neural network like the human brain. So this is called the deep learning, right? Now, when you compare the scope and application, one AI is called a very broader sense, and machine learning is a narrow sense, and deep learning is the narrowest. So like that, include machine learning, deep learning expert system, robotics, computer vision, natural language processing, symbolic AI are present in the AI. But machine learning is called a data-driven with algorithm. So machine learning, what happens? You given the data, you given the algorithm, you predict the result. In machine learning AI, what happens? You given the data, algorithm you to run and give the output. But in a DL, what happens? You given the data, you given the algorithm, you given the output also, and measure the performance. So in this way, the deep learning work. The core technique says that the AI is always nothing but the rule-based system, antecedent consequence, rule-based system. If you give an effort, output is pass. If no given effort, then not given effort, output is fail. Like that, AI will work. But machine learning says that on basis of supervised learning, unsupervised learning, reinforcement learning, regression, classification, clustering, all this we discuss in a machine learning. But this deep learning says that these are the convolution neural network, recurrent neural network. LSTM is just the last scale text multiplication is there, and transformation GAN method also there. We'll discuss details by using one by one. Now, coming to data types. What type of data consider the AI model? AI only consider the structure and semi-structure. Then, and machine learning basically mainly consider the structured data and somehow consider the unstructured data. But deep learning purely consider the unstructured data on terms of image, audio, text, and the video. If you combine all these things, so this is called the unstructured data. And unstructured data only is not helpful by the AI, you only helpful for the deep learning. And deep learning gives the very good result if you supply the unstructured data. Then learning dependency may or may not be involved learning in AI because antecedent consequence, no such learning is required. But in ML, what happen involves learning model in historical data. Historical means past data, we can do time series data. You got historical data. On the basis of historical data, he predict the output, right? On the basis of historical data, machine learning will tells. But here what happened, not only historical data, he is fully dependent on the large scale learning with the neural networks. It's not historical data, it's a large scale data required in unstructured format. The deep learning will work perfectly. Now come to complexity is there. AI having less complexity because decision tree is having less complexity because your data structure is nothing but a very less structured data. When machine learning, what happened? The moderate time complexity or system complexity is there. But here what happened? We can deep learning is very, very complex, huge number of data is like multi-layer neural networks are there. Now coming to complexity, time complexity or system complexity, you can say. Here the low complexity, high dependency. Here moderator complexity, we can on the in our system we can do it. In your laptop we can do it by machine learning. But in deep learning, if you do actual deep learning work, then the CPU will be the fail. You need the GPU based server. Then train the large model. People are using in your laptop also deep learning, but give the result accordingly, but you take some time. But if you GPU, you take you do 1 year time, 2 year time is required, right? In Indian metallurgical department, they are using the GPU by weather forecasting by using deep learning. They can use. Now, so what is the process for the deep learning? The process of deep learning first is understanding the problem. As I already told you, understanding the problem is a first important in a deep learning. Whether deep learning is applicable or not applicable. First, you would identify, first and foremost, you define what exactly problem is it. What is your hypothesis design? So that you would design. After that, what happened? Train the algorithm. Once you train the algorithm, you can find the different type of labels. I'm given one type of gates. Then identify a relevant data set and prepare them analysis. So Kate, what are the features are there that will automatically identify this machine learning. Then the machine learning will find the test the different type of model in terms of performance against unlabeled data. Then after that, what happens to the type of deep learning algorithm to use? What type of algorithms are used in deep learning? Deep learning having n number of algorithms are there. You can use different type of model. Suppose you use the CNN, convolutional neural network, and convolutional neural network also having 100 type of convolutional neural network. That depends upon version 1, version 2, GNet, PNet, like that, you can do it. Now, how deep learning works? Deep learning basically work on the basis of a neural network. If the layer is interconnected nodes in the neurons that collaborate to process the input data. And every deep neural network concept, the neural network must be fully connected. What does it mean fully connected? Fully connected means each neuron must be able to pass the information to other neuron. So this is called the fully connected. This is called the fully connected neural network. If you compute this one, this is not called the fully connected, right? It's not a fully connected, right? So here what happened, we can find all the data points. You can find what? You can the data neurons able to transfer the data to next neurons. That is called the fully connected. And deep neural network, deep means the number of hidden layers. If number of hidden layer is 10, 20, 30, that means a huge number of complex data they can generate by transfer the data from one neuron. On the basis of transferring data, that weight function also work. On the basis of transfer data, we can get the learn the process. The network neural network will be the learn the process. Finally, the output generate the model prediction. We can call the different type of neural network. One is called the feed-forward neural network. One is called the convolutional neural network. One is called recurrent neural network. One is generative adversarial neural network. One autoencoder transfer. So these are the few things I'm showing here. These are the few things of the part of the different type of neural network, right? Here autoencoder means every neural network has its own purpose. Suppose the problems working in a feed-forward neural network may not be work in a CNN. The problem work in CNN may not be work in RNN. Problem work in RNN may not be work in GNN. And those are working in GNN may not be work in a autoencoder. So that depends every neural network having own specification. Which neural network work, that you have to define on the basis of your problem identification or problem definition. Now, difference between machine learning and deep learning. Okay, I discussed with AI. Now AI is no more. Now coming to machine learning and deep learning, right? Look at the diagram first. In diagram, what happened? This car input I'm given. In machine learning, what happened? I extract the features. So what are the extra features? One is a wheel, right? One is called the door. One is called the size. One is called the color. One is called the kilometer per speed. One is called the brand name, right? One is the price. So these are the features I've collected. I input the neural network model and it will give the output is equal to car, right? But in deep learning, what happened? The feature extraction is not there. Now you can ask how will extract feature? Given input, it will be extract the features. Then automatically they did classification on the basis of your algorithm. Then output is given whether it is car or not car in terms of the probability, right? So this is called the deep learning will be work. So basic idea in machine learning, you are using the statistical algorithm, learn the data from the previous data, then deep learning what happened? Artificial neural network learn the pattern. Data requirement is nothing but small to medium data set. Here large amount of data set in terms of terabyte or gigabyte. Text complexity is better, simple and low level tasks. Here complex tasks like image and text processing. Training time what happened? Time to less time become train because the data having a structure, semi-structure. Here data having unstructured, that's why more time will take. Here time may be in terms of hour, in terms of day, in terms of year, like that. Feature extraction is not about a feature are manually feature selected and extracted. Here what happened? Automatically the feature extracted. No need to give manually feature extraction. Very, very careful here. Don't give feature extraction by manually, automatically extract the features. The learning process one end to end. Here what happened? End to end learning. Here what happened? Not end to end. Here the model complexity is less complex, is a highly complex. Too much highly complex here. Here interpolability is nothing but easy to understand the explain. Here very hard to difficult to explain here. Then and the last one is called the hardware requirement. I already told you CPU base. Here the GPU base. Then the use case are the detection, recommended system. Here what happen? Image recognition, NLP, speech recognition, in HR also many applications also there. So I'll discuss one by one in what the HR application in my consequence slide. Now evaluation of neural architecture, I already told you in 1950s. I all in my introduction slides. Just I'm repeating. Now even the multi-layer perceptron. Now coming to in 1968 and the multi-layer processing by using trained by a backpropagation neural network learning relationship will identify, and this is the origin of the deep learning. So the very basic model of the deep learning people are not using now, but people are using in India 1968 up to 2000. You see most of the publication are multi-layer perceptions. Many researchers were doing multi-layer perception, right? But now you can multi-layer papers and paper will be rejected. It's not published by the multi-layer perception. It's a very outdated course. Now, the type of neural networks, as I already told you, feed for neural network, convolution neural network, generative by automatic transport neural network. So these are the I already explained. So no need to explain again. I'm given very briefly here. Now, as I already told you, every neural network has its own purpose. So I'm given which neural network best for what purpose. That is the we can discuss here. As of now, we already discuss ANN. There's a general tax, just like a predicting salary, employee engagement. CNN basically useful for the image recognition, medical image, face detection. RNN basically useful for the time series prediction, or suppose you can predict the dollar price. It will be RNN will be work. Speech recognition, text processing. LSTM, long short-term memory, is nothing but the language modeling, stock prediction, machine learning. Basically, this is useful for time series data. Now
Can I
people are
interrupt a
not
little
using.
bit?
Hello?
So I just had a question. Can I just ask right now?
How? Why not? You can ask anytime. Tell me.
So when you say RNN can be used for time series prediction, can it be
Yeah.
used to predict share market trends and
Yes. RNN work. Yeah. RNN. I'll show you many papers. RNN people are working. In LSTM also working time series. Previously, time series are the ARIMA methods are there. ARIMA methods are there, right? And moving average methods are there. People are not using ARIMA and moving average method. Now the time series is the long term memory. And long short-term memory, only the artificial neural model or the deep learning model only work for the time series data, means historical data. Is never work any other type of data. You can use but output is not reliable. So it's very performable work in the LSTM data, right? So are you understood what I'm saying? Why LSTM is work for the time series data and why not other data? It will be work, but output is not there. Okay. Suppose I can tell efficient. So efficient means doctor sometimes prescribe this medicine you take before food, this medicine take before or after food. Why? Because that medicine is better work if you take the before food. The same medicine you take after food, it will work, but that much of gravity will not work. Are you understood? Same thing. The LSTM will basically work for the time series data. Other also work, but that much gravity is not there. Okay, that much depth will not work. Similarly, autoencoder. Autoencoder basically the compression technique they call dimensional reduction or noise removal, anomaly detection for autoencoder will work. Similarly, generative adversarial network GAN model will work for image generation, deep fake art creation that will be work. Now, in your mobile, face detection is there. Previously, it was not there. Only finger detection is there, right? The face detection now every mobile having app, suppose SBI, and other application like HDFC app, they are using the face detection, right? So that is nothing but your transformer learning model. That they use the transformer learning model. That is called the GEN model. Now coming to transport learning model, the chat GPT, or you can call the chatbot translation model like GPT. Chat GPT also used by using the transport learning model, right? So now in the ISATC website, you open that GPT will become, right? So that is called the chatbot. So that is on nothing under your transport learning model. Now coming to deep belief neural network. So this is originated 2010 onwards. People are using a less number of work has been done. Deep belief neural network basically use the feature learning. That means automatically feature learning use the feature extraction on supervised learning model. Then finally last one you can use the deep RL reinforcement learning with deep neural network. This is a combination. This is called a hybrid. This is called ensemble technique. This is called the ensemble technique, hybrid technique. A decision making problem like robotics can identify surveillance. You can find a robotics and game planning. Now in T20, you see the robots are moving here and there. You can go today, you can open the T20 match, you can see the robot is moving, identifying the balls and like that. Okay. So that is nothing but the deep reinforcement learning and the deep neural networks using AlphaGo is one of the example robotics. So these are the advantage and disadvantage. This is also there. In deep neural network also disadvantages also there. One is called the data requirements also there. Then high computational cost. Then also the overfitting, lack interpretability, training time, hyperparameter tuning, bias. So these are the nothing but your disadvantage of the deep neural network, right? Now, the challenging issue, as I told you, though, right now I'm telling you, these are the challenging issue. Deep neural network is very difficult to handle when you use deep neural network, but you can compromise. You cannot compromise overfitting, underfitting data. If the testing data time error is less, training data error is more, then overfitting coming to picture. Data quality also required. Garbage in, garbage out, right? So data quality must is required. Computational resources also there. You must have a GPU. Everybody GPU is not there because GPU is high cost, so very difficult to get everyone a GPU. Interpretability also problem. Hyperparameter tuning means which parameter you're considering more tuning, that also important. So these are the different we can call the challenge in the deep learning concept. There's the application. So these things no need to discuss again. You know the application. Coming to your managerial perspective, application learning in a HR. So one is recruitment and talent acquisition. So one is called the automated resume screening by using deep learning model. Then shortlisting. So what will do if you are not using model, then submit the CV, extract the CV, then output the CV, then everything you can put in Excel, then find out, then analysis, then application, scrutining, then review, then interaction, then background study, then reject, then you even also give an offer. that client may be that candidate may be decline your offer, then finally you can hire. So these are the long process is there. But if you use the AI tool or we can call the deep learning model, automatically you can find the shortlist resume. Reduce the human bias and hiring time. Example, AI-based applicant tracking system that you can also do. Then coming to next, employee performance prediction that also can do. Engagement impact factor, how much engagement, manager activity, people impact that you can find out. And another things we can call the employee engagement analysis. We can find the attention prediction, then retention strategy, reduce attention rate. A company having lot of data you can find out, performing scoring, comparison. Finally, software can for HR staff you can develop, make employee attention prediction. We can do it. Now, learning and development also there. The HR chatbot is there. Suppose new guy is joining, so if you develop HR chatbot, the person will ask what the reimbursement policy. So no need to write a mail to HR manager. No need to ask your friend. Automatically, a chat will tell. So HR policy is this much. Now, how much tax I have to pay? Automatically, chat will tell. How many leaves are left? Automatic chat will tell. Like now, in what happened? In you can see different type of apps are there. Yono app is there. Now you can see SBI, then HDFC. In WhatsApp, what happened? They'll tell lot of information like your bank statement or balance inquiry. So previously what happened? You go to bank and find the balance inquiry. After that, what happened? The ATM come to market. You push your ATM card and check the balance. Now what happened? ATM card is not required. No need to go to bank. You open your WhatsApp and that automatically asks number one press balance will tell. Number two current balance will tell. Automatically it will be tells. That is nothing but your chatbot. Similar employee self-service also there. Ask about the policy, discover training opportunity, review, then look at the payroll details. All the information I use in the 24/7 chat employee support is there. So these are the various application of your deep learning to reduce the workload. Previously, what happened? You can open the bank or huge number queue was there. Now you can see the less number queue. I mean, very less are there in your bank. Bank is smoothly running. Similarly, workforce planning, forecast workforce need, strategic planning, and the resource allocation. Now, the last one is there. Payroll fraud detection is there. Diversity inclusion, employee well-being. Suppose a employee having stress. Okay, suppose Professor Datta too much stress today. So you can find a analysis how much stress you can measure your stress level. Once you measure stress level, what will do? You can do yoga meditation. Your stress level will decrease. So that is called the well monitoring stress level, improve health quality, enhance the productivity. Diverse includes nothing but the detect bias, promote fairness, and the inclusive policy. So these are the different type of application in your deep learning is concerned. Manual detection is very difficult. Chances of manual detection error might be high. So that's why automated AI tools give the detection time to 9 and success rate also increasing in AI automated tool rather than the manual detection. So these are my today lecture. So I'll start in deep learning applications in the next subsequent paper. Any doubt you can ask me. Any doubt?
Sir, I have a question to ask.
Yes,
So,
yes.
this ChatGPT, Claude, are all pure AI or
Deep
it's a mix
learning.
of ML
All
or
are deep learning model. Yeah.
okay. So,
Mm.
how does that work? Like,
This is I told you now here example how this will work application I given. See,
Mhm.
this is the deep belief network and reinforcement learning. They're using this one ChatGPT extraction learning feature to automatically extract. Again, they use also generative advanced neural network also they use transformer learning also they use. See, not
Mhm.
only they have one model they have to use, right? They combination of all the models. That's why it's called the ensemble techniques. Not only one model they use, they use all the different models. The
Okay.
data mining models they also use, right?
All right, sir.
Any question? Any question?
Adding to previous question. So, since
Yeah.
for example, this Claude and ChatGPT work on combination of all this model, So suppose, sir, for comp and ben, what you given, taking the example, I took all the inputs, give it to Claude. So will it work like our code, our studio, or maybe other?
You write a ChatGPT kindly write the R code for the dimension reduction. Automatically they give.
So they will give the code, right, sir?
They'll give the code, but
Uh,
that you have to sure that whether the code is work or not. You have to analyze it and you have to execute it.
okay, and that code I will copy paste in R.
Or you can run the program.
So, sir, what is the difference between the results given by ChatGPT and R?
See, ChatGPT, you give the problem and give the ChatGPT. Suppose ChatGPT may be wrong, right? But your human being cannot be wrong, right? So you have to
Hmm.
write a programming code. Then you
Hmm.
have to analyze what should my input, what should my output. On the basis of you can compare the result with your ChatGPT result, right? If ChatGPT result is very very near to your result, so you can accept the ChatGPT result.
Mm-hmm.
No problem.
All
See, I'm giving one real life example. Yesterday I came by train. So my chart paper, someone B2 A1 28, right? I asked the chart GPT, tell me the which berth, which is upper berth and lower berth, right? The chart GPT given lower berth. The moment I go inside the train, I found it is upper berth, right? So this is the
Mhm.
information happening. So you chart GPT, you don't rely everything and what ChatGPT gives result, right? So like that you can do it, no problem.
Mhm.
Hmm.
All right, sir. Thank you, sir.
Yeah. Any question? Okay, madam, should I stop here?
Any more questions?
Any more question you can ask?
So, Professor Mohanty, you can conclude here then.
Yeah. So okay, conclude. So you can see next week. Okay. Any doubt we can discuss more. Okay. I've given the R code and the PPT today. You can go through it. The R code I'll give you again the PDF file.
Thank you, sir. Sir, thank you.
Thank you.
Thank you.
Thank
Thank you, sir.